Hello everyone. So here it says that suppose there are 3 defective items in a lot of 50 items, and it says that there's a sample of 10 taken out without replacement. So first thing first, when you see a problem that tells you there are such a number taken out of that number, or there are this type of number in certain type of number, and that there is a sample that is taken and without replacement. First, think of hypergeometric. Basically, you have 50 items. Now, I'm going to show you something. The hypergeometric is you have one thing here, but you have 2 on top. Now, let's fill in the blank. They're asking you for exactly 1 defective item, so that means x equals to 1. Now, what goes here on the bottom? On bottom here on top, if you need, in the denominator, the biggest number goes, or the biggest numbers go in the denominator. So what are the biggest numbers? It's 50 and 10. Why? Because there are 50 items and there is a sample of 10 that are taken. Second, on top goes the smallest number. Now, in the first one, we know that there was a size of 10 items taken, but 3 of them are defective. So 3 on top are defective. And so that means because we have 3 defective items in 50 items, so there are 47 that are not defective. But now, you see the top plus the top needs to equal the bottom top. Now they're asking you, the question is, find the probability that exactly 1 item. So because we're asking for 1 item, then you have 3 defective items, so 1 can be defective, which means 9 cannot be defective. And again, look at that. 1 plus 9 equals 10. So the top here has to equal the top here, and the bottom here needs to equal the bottom. This is what hypergeometric, that's the hypergeometric formula. Now what would that be equal to? And this one I will show you in a calculator instead of do it myself. Now I'm going to put up my calculator. Actually, if you have a TI-89 or H9 titanium, they both work. So if you here I couldn't find a virtual calculator for a TI-89 titanium, but I got this one. But actually it's the same exact thing you do, the same thing, same thing. So if you have a 89 titanium, this is what you do. You click open parenthesis, click the second button, click number 5, click number 7, and click number 3. What you can do now is you can copy this. You can copy, and then now you press copy, and then you press escape. So once you copy, you press copy. That is to copy the NCR. Then you press custom, or the green button, and then click copy, and then the green button, and click escape or ESC to paste, and then you can paste it again depending on how many times you will need it. So now we can go back to here. The first one, we're going to put the combination 3, 1. So we type 3, comma 1, then close parenthesis, times, then you can do the second one, which is 47, comma 9, and close parenthesis, and then close it to finish, divided by, now the bottom part is 50, comma 10, and close parenthesis, and you press enter, and you get 3.97. So now the answer for that question will be 0.398. This is the probability that exactly one item is defective. Now, the probability that at most one is defective is the probability, which means probability that x is less than or equal to 1, is the probability that x is equal to 0 plus probability that x equals to 1. Because it's at most 1, that means it cannot be more than 1. So we already have probability for 1. Let's look for the probability for 0. So probability that x equals 0 would be, we know that already. We have 2 on top and 1 on the bottom. So on top we would have 3 defective and 0 defective, 47 non-defective, and then 10 not defective, and 50 and 10. And go back to the calculator, we could just change these numbers here. That would be 47 and 10. And then that would be 0. Now we can press enter, and we get 0.504. So that would be 0.504. Now the probability that that one would be 0.398 plus 0.405. So 0.398 plus 0.405 or 4 equals to 0.902. So this will be 0.902. And that's it. So we are going to do more example on that, so you guys can understand when it talks about hypergeometric, so you guys understand how to understand. Yeah, so you guys can understand how to understand when a problem is about hypergeometric. So I hope you understood. If you like it, thumbs up. If you don't, thumbs down. If you have questions, please comment, and I'll try to answer them as soon as I can or whenever I see them. But other than that, that's it for today. Have a good day.